Well, today we have the 19-inch medium res K7000 on the bench out of the Paperboy machine at the arcade. And the arcade attendant was turning all the machines on the other day, sent me a message and said, hey, the Paperboy monitor is black. I said, okay, we'll go over there and hit start, see if you can hear the game running, play a little bit. And sure enough, you could hear the game running. It appeared to play just fine, so sure enough, the monitor was dead. And when I say dead, I mean totally, completely, utterly dead. I went to look at it, and it has no signs of life, no electronic sounds, no noises, no nothing, like the fuse is blown. Now, I've already I've already repaired this previously from the width coil burning up, which I'll link the video to that down below. But I also took this out of the machine and immediately took a look at the fuse. So this is completely dead with no signs of life whatsoever. Oh, sorry about that. I'm batting 1,000. First I slammed the viewfinder shut and the battery dies. I forgot to plug this in. I don't know where the camera shut off, but basically, yeah, the tube is so tired. The red gun is almost non-existent. I've already rejuvenated this thing twice, and it works for a couple of months and just starts getting worse and worse again. So this picture tube needs to be swapped. The problem is, this is one of those all-in-one. I believe this is a 100-degree angle tube. The picture tube here, the neck angle is different on some tubes than others. There's 90-degree, 100-degree, and 110-degree. Now I'm pretty sure this is a 100-degree yoke. The problem is if you have a 90-degree tube, glass formature here, this won't fit on there. It also won't fit on 110-degree. Now, this is why it's the amateur channel. I'm not 100% sure if this is 100-degree, but I know for a fact that if you have a regular standard 19-inch with the regular yoke on here that has the separate ring assembly for the convergence, where it's not all in one here, I know for a fact those are a different angle of deflection here on the glass tube. So I know for a fact these won't fit on there. You won't be able to take this yoke and fit it all the way up against the glass like this. It sits back about 1.5 inches, and that will severely affect your ability to have your full deflection, and it just won't work. So I don't know if we're going to be able to tube swap this unless I can find a tube with the proper angle of this portion of the tube to allow the yoke to fit all the way up against the glass. So I've got two spare donor tubes here behind me off camera, and we may try to use one of those. I have nothing to lose because this is all one assembly. There's nothing to it to just take this off of here and try and fit it on another tube, because if it doesn't work, I can always just put this one back on. I don't have to worry about convergence at all because this is already affixed in place with the yoke, and it's all, you know, hot glued together from previous, you know, rejuvenation and convergence attempts. So all you gotta do is just take this and put it right back on, center the yoke up, and it's right back to where it was. You don't gotta worry about trying to put the rings in the right spot, turn them the right way, all that. I can put it right back on with no detriment to the process here. So the first thing we're going to do here is try and get the chassis repaired. Once we get that done and get it up and running, you'll be able to see just how tired and bad this tube is. And then we'll see if we can try and figure out how to swap this tube out with something that might work. So let's get the chassis fixed first, then we'll worry about the tube and kind of go from there. Oh, scratch that. Sorry, I forgot. I talked about how I was going to turn it on to show you that it's dead. I forgot to do that. So I have the power hooked up and we're all connected and everything the way that it's supposed to be, just how it came out of the machine. And if I turn this on here, 1, 2, 3. Nothing. You can see that power supply is on. You can hear the vibration, if you will, of the frame kind of boom, but that's all you get. I'll turn it on again, 1, 2, 3. See, now there's nothing. Off. On. The isolation transformer doesn't even make any noise. Listen. On. Nothing. Power supply is on. So we've got voltage. This does nothing. So, yeah, let's get this camera on the overhead, get the chassis off, and go over it and see what we can find. Okay, so here we have it. So the previous repair, I had to fix this width coil because it completely just burned itself alive here. So the whole frame and traces and the whole entire board here completely burned itself open, and I had to use a little piece of solder braid as a trace repair, and it ended up working just fine. Like I say, I'll link the video down below and you can go check it out for the full repair. But it's been working fine ever since, and now it's dead again. So the first thing I want to do is just start going through a visual inspection here. If we see anything that might give it away. And right off the bat, I don't see anything visually. There's no signs of arcing on the side of the end of the frame here from the flyback. There's nothing visually that I can see on the top side. Nothing's exploded. No caps burned up. Nothing really that obvious. I am missing the zip tie there for those wires. I guess I forgot to put that on last time. Okay, the bottom side. Again, I don't really see anything that has blown up or been destroyed. I've already done the reflow with, you know, R89 and R101 and things like that, and R96, and you know, I'm wondering if Q10 might be bad, because Q10, this transistor right there, that guy there, that if that's faulty, the chassis will be dead. So I'm wondering if that's any good. You know, you'd imagine if the HOT was shorted or the voltage regulator was shorted, the fuse would blow. You know, it stands to reason that's usually what happens. But the fuse is actually good. That's 1.5 amps. And if I go to continuity mode on the old meter here, it's good. If I take it out of the chassis and I check it, it's good. So the fuse is not blown. So I'm not certain that we have anything that has shorted. I think it's possible just simply that our Q10 might have died. And it happens. I mean, stuff like that, you know, components fail over time. There's not much you can do to prevent it. So let's just go ahead and check Q10 right off the bat. Again, it's this guy right there. So we are checking to make sure that it is reading correctly. If I recall, we should be able to put positive on the outside leg here this way, and 0.5 or so voltage drop to middle, another outer. Let's see what we get here. Nope, that's not right. Flip these around the other way. There we go, 0.5 and 0.6. Okay, well, I'm not sure if that's exactly correct, but it's not faulty. Going to reflow that middle leg there. So that's not our problem. I guess we'll go ahead and... Oh, and yeah, so there was a bad solder joint here on the flyback as well that I had to fix, that was just arcing itself crazy because it had a cracked joint and it was arcing across from the high voltage, and it cooked that trace as well. The medium res K7000 runs at a much higher temperature. It runs hotter than a standard res 7000, so you end up with stuff like this, the width coil burning up, flyback pads burning up, all kinds of stuff like that. So it's quite common for the medium res ones to do this stuff. I saw a joint that I was going to reflow there, and I lost it. Oh well. Okay, well, let's start going through the power circuit here, see what we can figure out. Alright, let's go to ohms, and R103 should be 2.7 ohms. Come on. I can't get a reading on that, so we'll do it on the bottom side here. Oh, look at that! Well, R103 is open. Yep, 23 megohm, 22 megohm. R103, open. Well, that would explain why it's dead. R103 is directly off of the AC input and the voltage regulator, so with R103 being completely open like that, that would explain why it's dead. So let's yank that out of there. That's not going to be good. Not sure if we'll be able to do this. I'm going to try and get the holder out here, and there you go. Just go from one pad to the next real quick, back and forth, back and forth, back and forth, and pulls it right out. Let's check it out of circuit. And yep, nothing. 40 mega ohm, nothing. Yeah. Well, okay, we'll have to change that out. And let's go through and see what else is wrong. And let's go ahead and... You gotta be careful doing it the way I just did it, because you can rip the pads off of the board here that offer the support. So there's two pads right here. I'll zoom in a bit. There's two pads right here that are support pads. There's three actually. There's three support pads for that frame for R103, and you got to be careful going back and forth into these pads and trying to rock this out, because you can actually, if you push, well, I would say only push this way. If you push this way, you can just lift those pads right off the board by trying to rock this way. So anyway, you know, you got to be careful when you rock this resistor, rock it inside out. You're gonna rock this resistor, make it scream and shout. You can't see what I'm doing. I'm just getting the solder off of the frame here, so when we go to put it back in, it should go in nice and easy. Okay. All right, we'll tackle that later. Let's go through and check our other components, because very first one we tested, bad. Okay, rectifier diodes, good, 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 and good. All right, R104 should be 15 ohms, 15.0. R101 should be about 5K ohms in circuit. I can get a decent connection on it. Okay, yeah, 4.2, which, it's okay. I think usually this should be closer to 5. We're at 4.2, so I'm wondering if our HOT is shorted, because usually if the HOT is shorted, you get this as a much lower reading. It should be much closer to 5 than 4.2. So I'm wondering if HOT is shorted. But we'll get to that in a moment. R89 here should be 3.9K. And we get 3.8, that's good. R97 should be 270. 270. R96 should be 1.8. 1.7, that's fine. K, 1.8K. R88 should be 1.8K as well. Yeah, 1.8. All right. Let's check our C38 width cap, make sure it's not shorted. That is this guy, these two pads here. Well, 1.8K. I don't know about that. And that's an odd reading. That may go back to our HOT being, yeah, it's 2.3 now. All right, let's check our HOT here. Negative lead in the middle, 0.45 voltage drop to each outer leg. Oh, there you go. As suspected. And just for a little show and tell. See, I knew that was probably shorted based off that R101 reading. Now, if I was to desolder the collector leg here, because these two are always shorted together in circuit through the rest of the chassis, if I was to desolder this collector leg, okay, that's not in the circuit. I'll bet you that our R101 now reads closer to 5K instead of 4.2. Yeah, there you go. Bam, 5K. So that's a good indication your HOT is shorted if your R101 reads a bit low there. So okay, so we're down an HOT and an R101. With that, let's see what C38 reads now. It's still 3K, that's odd. All right. What about our D18? Oh, there's no D18. The medium res chassis doesn't use D18 across the yoke header pins for some reason. There's no diode here. So it's not down there, it's not on top. That's common for the medium res. So no D18. C38 seems to be okay. Now, what about our C69 critical safety cap? Okay, that's good. Diagonal this way. That's good. We're just checking to make sure it's not shorted. Now, C30, I can't ever remember what this one, C37, there is a cap in here, and I can never remember what that one is. I think it's C37. But we're just checking to make sure that it is not shorted either, and it's not. There's a diode here, that's why we're reading like a diode. So that's fine. I think the only thing left really is our voltage regulator. Yeah, critical safety was good. All right, voltage regulator. Pin on this one, on the fat wide one, you're looking for pins 1 and 4. You should get a point, about a point 151, I think is what it is. Oh, well, that's shorted too. If we go to the B plus resistor, we should get around 220 ohms, I think. But we got 2.3. Voltage regulator shorted. So the red wire and the blue wire go directly to pins 1 and 4. So you can just go across these two pins, and if you read 2.3, it's shorted. So we've got a voltage regulator, an HOT that are shorted, and R103 is open. Now, I think what happened is the reason the fuse didn't blow, I think I may have found the problem too. I think I just found the problem as why this happened. R103 opened up, and with R103 out of the circuit, it prevented the fuse from blowing. So I think, I'll show you here. I think the HOT shorted and the voltage regulator shorted, but the fuse didn't blow because R103 opened up. But I think R103 opened up and cascaded these faults because of something I just found. So R97, look at the solder joint here for R97. Remember how I mentioned that the medium res runs hotter? Look at this solder joint for R97. Now, I had already reflowed all this stuff, and even after the reflow, I think R97's out of circuit. I'm going to pull on the resistor here. Look at this solder joint here. Oh no, it's in there. It's connected. It's connected, but that is not good whatsoever. Well, I can't pull it out of there. I mean, it's secure, but dang, is that over temperatured there. That should look like this, nice and shiny. That's all dull and dark. That is not good. It looks like it should have come out. I'm pulling on this here, and it's not coming out. So it's connected, but that's just bad. Let's get all that off of there and reflow that. If we go to the back side of the pads here, let's go to this pad and where's the other side of that thing? Oh, that's not a leg of R97. That's a leg of the linearity coil. That's a leg of the linearity coil. That is this guy here. That's what that is. Let's try this again. I thought that was R97. All right, I'm going to move this with this linearity coil here, see what it does. Oh, there you go. Linearity coil out of circuit. And I think that is the cause of our problem. Linearity coil out of circuit. That'll do it. Try to hold this tighter better here. Tighter better? Tighter better? Is that a word? We're looking here. Oh yeah, that puppy's out. Okay, well, I think that was the cause of our cascade failure. Let's fix that, because that would certainly do it. And you can tell I've already reflowed it and just, oh man, yeah, look at how oxidized that pad is. I'm not certain that it even was part of the circuit if it was soldered in. This is why it's important when you reflow, when you reflow, it's not just adding fresh solder. You're supposed to remove the existing solder. And look at that. Look at this. That's not even close to correct. Let me take this linearity coil out of here and I'll show you how to fix something like this. So okay. All right. So let's show you how to repair this. Get this back in frame. I need to get rid of this. That's what you want to see when you remove your solder. You don't want to see this. That's and like I say, these medium res 7000s run much hotter, and you end up with stuff like this all the time. And that should go back in fairly easily here. Get rid of some of this stuff on here. Okay, now with that done, so get yourself one of these fiberglass spot sanding pins, and I'll link this down below, and you'll see here that I can magically restore this pad here. The pad's still there, it's just severely oxidized. So if we just scrape this off here with this fiberglass pin, this is actual fiberglass, not that fake stuff that they call fiberglass. Oh no, that pad is gone. That pad's completely gone. That pad is completely gone. Nothing's left there but the PCB material. I thought that was still there and just oxidized. Well, it shows how much I know. That's why it's the amateur channel. So, with that like that, I want to scrape a little bit more of this away here. All right. So with that done, we can try and do this a bit better here. And we need to scrape away our legs of this here, because this is all completely oxidized too. We want to get rid of all that oxidation. Look at that now. Glorious. And we'll do both sides of this. All right, I think that should work there, and we'll go ahead and do the other ones too. This one's just an anchor point, but we'll get it anyway. You see here the coil only actually goes to these two. This is just an anchor point that goes to this pad there. All right, so let's put this back in. And I'll bet you dollars to donuts that after we change out R103 voltage regulator and HOT that this will work again. And that'll be all this puppy needs. And I have to put this thing back on here. I'm pretty sure it went this way. So this is an extra magnet, and it goes on top of that, and it affects your linearity. If this is missing, your image will be slightly off one side or the other, and your linearity, not just the position, I mean the linearity. So we need to make sure to put that back on. I'll have to glue it back on later, but for now we'll get this back in here. And wait a minute, did that fold over on itself? No, what in the world? Oh, okay. I desoldered the wrong pad here. Unfortunately, there's not really a way to prevent this from happening in the future, because I've already done this once and it still burned itself up again. So I can go through here and do this, and you know, another 2, 3, 4, 5, 6 years from now, this is just going to get burned up again. That's just the nature of the beast with this stuff. So let's go ahead and get our anchor point in there. That's good. Let's grab this one. I'm going to actually just kind of bend this over a bit if I can. And sometimes you can use your solder, the end of your iron here, to kind of scrub away any remaining oxidation. That's good. I know this looks terrible, but trust me, this is the only real way to kind of somewhat even come close to making this thing bulletproof. So now I need to bend this over to get closer to the pad. There we go, bingo. And we'll try that same maneuver here. And when you do something like that, you're allowing more, it's acting like a heat sink. By adding all that big solder blob there, it's acting like a heat sink to give it more surface area to dissipate the heat than just that tiny little trace part right there. So that helps in the long run also. I'd like to get a little bit more on here. Okay, that's better. Well, it was till I knackered it all up. Now it's knackered, as they say. I wonder, yeah, let me try and bend this over the other way here. Nah, it's not gonna work. Well, probably gonna have to just live like that. I'd like to get a little bit more. That's better. Okay. It's better from this angle. You can't see, but it's better from that angle a little bit. Well, okay, I think that's going to solve our problem, but we got to replace these other components now, so let's do that. Hopefully this won't take up a big chunk of the video, because it's going to probably be a while for us to try and, I mean, if we do find a tube that yoke will work with, it'll be a breeze, a complete absolute cinch of a breeze to swap it out, because the rings and everything are part of the yoke assembly. Like I say, you just slide it on there, angle it where it's centered left to right, and you shouldn't have to do any convergence at all. Assuming you can find the correct degree of tube. Now, I don't know what degree that tube is. Like I say, you got 90, 100, 110. Now, normally the tube will have stamped in the glass the angle, whether it's 90, 100, or 110. Usually the tube will have it stamped in the glass, but more modern tubes don't have that stamped in the glass, and I don't know if we're going to be able to find one that is the right degree. And so I'll do some digging around off camera and some testing, and we'll see what we can find. I think I'm going to go ahead and just pull the yoke off of this tube so I can try and find one that'll fit on, because again, I can always just slide it back on and make sure it's angled left to right, and I shouldn't have to do any reconvergence on it. So because those rings are part of the assembly. And I'll leave this thing off of here so you can get an idea of how little or how much it can be affected, your linearity, by not having this on there. That's why it's there in the first place. So, all right. Is that gonna stay there? It's gonna stay there. How about that? The insulator I'm talking about. Okay, so now out of circuit. It's always important to test your components out of circuit. If I can get the stupid thing out of there. Alright, now I need my stash here. We gotta find an HOT and a voltage regulator. What in the world? How'd that happen? Weird. This cap was sitting way up. Okay, make sure this is still good. Yep. Alright. Alright. Sorry about that. I got sidetracked there. That one's not going to stay there, but that's okay. Alright, so HOT out of circuit. Shorted. Voltage regulator out of circuit. Shorted. Okie dokie. So we need an STR3123, and I have those right here on top of the pile. All right. That's a 130. Wait a minute. Are these 123s? These are 130s, you dolt. So the last, these are 130s. This is a 123, as in 123 volt regulator, 130 volt regulator. So the last three numbers there tell you what you got, if you ever are uncertain. Okay, I gotta find an HOT and R103 anyway. So let's just, oh, here's the HOT. All right, brand new one there. We gotta need our voltage regulator, which, please tell me I've got some. I've got plenty of this. I got plenty of this style, but none of the 4. And you usually can interchange those, but this one doesn't have the extra set of holes. Some of them have the set of holes for the 4, the fat one or the tall one. This one only has the holes for the fat one, and I'll be darned if I don't have a fat 123. These are all 130s. Maybe I can, oh, haha, I got one! You guys are lucky. And then I have an R10, that's 1123. Now this is, this is an R103, pretty sure. Let's check it. Yeah, 2.9 ohms. Okay, yeah, I got R103 here. We got our HOT, and we have our lone voltage regulator. I'm going to have to order more. So there's our 3 parts. Let's get these installed real quick after I put all this back together. I need to get a bigger container here. I need to order more R103s and more 123 regulators. Okay. So let's get our regulator in there. Nice. Okay, and HOT, we gotta bend our leg backwards slightly. Oh, not that one, you dingbat. Middle one, and then bend it like that. You should end up with something like so. And this is gonna go right here. Make sure your middle leg isn't touching the heatsink. And voila. You couldn't see that, but it went in nice and easy. Easy, breezy, beautiful HOT girl. And we'll use our pliers, or our, not pliers, come on. Can't think of the word. Tweezers. Jeez. To hold our nut in place while we... Gotta hold your nut in place while you screw. You don't want it coming loose. Alright. So, now let's tackle R103. And we're gonna have to open this up a little bit. Open this up a little bit. And this one. And this one. And we need to just go ahead and cut this. This should slide right out. Ta-da! And we'll wait on that. Now, did this... You can see right here where it likely opened up, right there. Now let's get this guy in here. This way, I think. Come on, you piece of junk. Okay, there we go. Now we gotta squeeze this back together. It doesn't have to be super secure, but you know. We'll just kind of I think that'll work. So, yep, alright. Oh, no, that moved right out. Maybe that won't work. You got to know when to hold 'em, know when to fold 'em. Doom, 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 doom. There we go. Got it. When the dealing's done. This should go right in. There we go. You pop any pads off? Nope. Make sure it's flat. And we have a successful R103 replacement, a successful HOT replacement, and a successful voltage regulator replacement, and a successful linearity coil repair. You guys were thinking I was going to forget this, weren't you? Well, you'd be wrong. Alright, now let's solder these guys in here. And these pads are long gone from all the replacement HOTs over the years. I could do the light bulb test, but I'm not going to because I want to live dangerously on this one, and that's how confident I am that it's going to work. Okay. Now, yeah, with a horizontal linearity coil out of circuit, that will definitely cause problems. So, I'm not sure if the R103 opened up first and that took out the HOT and regulator. I don't know the series of cascade failures, but however it failed, it saved us a fuse. And I was trying to understand how in the world could HOT and voltage regulator be shorted, but you know, as I was sitting here thinking to myself, but obviously if R103 completely opens up, you're not going to have any pathway through the fuse to cause it to blow. So I think R103 might have been right on the cusp of failing, and when one of these components failed and it backfed through this way, it prevented the fuse from blowing because R103 went out before the fuse went out. So, okay. Is that everything? I think that's everything. We resoldered this linearity coil. Okay, so I'm pretty sure our chassis is now repaired. I'm going to clean up real quick. I don't always show this, but sometimes I do. I turn my fan off so it doesn't evaporate all of my alcohol. Now I like to use denatured alcohol as opposed to isopropyl, because the denatured actually cleans much better, cleans all this flux off much better than the regular isopropyl or isopropanol or whatever you want to refer to it. It takes very minimal effort to clean all this off of here, and it evaporates quicker and better, and I just like the denatured better. My personal preference. You may not like it. I like it better. Okay, so our chassis should be good now. All right, so we'll set this aside. Now I'm going to take the yoke off of this tube, and maybe I can try and get this on camera here. Let's put this out of the way. Clean up a bit here. That goes there. These go over here. All right. Three bad components in the garbage. And we'll have to remember to put this back on the linearity coil, which we will. Once we turn it on and look at it, we'll see, oh yeah, we gotta put that back on. As a matter of fact, I'm gonna go ahead and plug the heat gun in, or the hot glue gun for now. Now, okay. When it comes to this thing here, as I've mentioned multiple times now, it's all one assembly, so we can simply unscrew it, and it just turns left and right, and it should just come bloop, right off. There we go. And I notice now that all of our things here are broken. It's just so brittle from heat. Oh my lord. If I screw this up, we're going to have a very bad day. I need to not... I still have some left here to grip on. I need to be careful with this, but you know, all I gotta do is just slide this back on and make sure it's straight and you're done. So I'm gonna have to see if I can find a tube that will work and do some experimentation, and I'll come back and we'll see what we can... Oh, you know what? I'm an idiot. My skull is so numb, I just don't know what's wrong with me, because I forgot to hook the chassis up and show you what this looks like beforehand. All right, I don't need to clamp it on. We can just leave it like that for now. I almost forgot, because we have to see what this looks like and test the chassis first. So yeah, man, I'm batting 1,000 here. And of course the yoke connector is all burned up. I should change it out, but I can get around that for the time being. Oh, come on. There we go. Okay, yoke is connected. Degauss coil is connected. Set the chassis in the frame. Put the ballast box over, out of the way. Hook up our neck board. Hook up our anode cup here. Okay. Let's connect our ground. And we are ready. Let's spin this around. And I will take you off the overhead here. We'll hook up the test pattern generator. We'll fire this up. Hopefully it works, and we'll show you how bad this tube is. Alright, so we're all hooked up. TPG. We're set to medium res. We'll turn this on. Power is connected, so hopefully now it turns on, and we'll see what happens here. 1, 2, 3. Yep. It's on. And sorry about... Whoa. Something is something is not happy. Ooh, something is cooking. What is it? Ooh, I can smell it. Whew. Something is cooking. Is it our flyback? I'm going to turn power, or the light off. I'm going to turn power on. 1, 2, 3. No. Something is... what is it? Ooh, it's working again, but something is... Oh, hang on, what's this? Improper inspecting on my part? No, I was looking at this right here. Oh man, something is cooking and I can smell it. Dang. Alright, sorry about that. I had to do some reconnecting of the ground wire there, the DAG wire. It's just loosely plugged in here and it came out. But we got smoke, little puffs of smoke coming out the side of the flyback here. I'll see if I can focus in on this. Alright, I'm going to turn this on. 1, 2, 3. Well, now you're not going to do it? Oh, there it goes! Oh! Our flyback is toast! Our flyback is toast. Alright, well, I'll grab one, we'll put it in, and we'll try again here. I spent so much time praising this flyback, but I think what... Oh, crap. Shit. I spent so much time praising this flyback, but I think with the other component failures, just stressed it too much and it died. Not because it's no good and it won't work. I think it just stressed it too much. Let me get that changed out. We'll try again here. Oh, man. Jeez. Okay, so brand new flyback's installed. And I went ahead and changed out this 22 microfarad cap because I didn't change that before for some reason. So brand new flyback. I've turned up the screen pot about on a 1/4 turn. That cap's been replaced. Everything is hooked back up, ready for testing. TPG. Oh, I also went ahead and just said forget it. And I had the hot glue in place to hot glue this cap so it wouldn't move around. I went ahead and just installed that thing on top of the linearity coil. I mean, obviously, you know, if you don't have that installed, it's supposed to be there, then you'll have, you know, the dead center of the screen is supposed to be dead center, might be off a little bit, but, you know, that's what that is. I'm not going to show you. You've seen it before. So, we're ready. Oh, and the old Flyback, I'd say, yeah, it's bad. Just a little bit. So, obviously, this didn't explode in half. Well, it might have exploded in half there on camera when they let all the smoke out, but I think it might have been on the cusp. I think it was already split, and it might have been on the cusp of exploding. But anyway, yeah, that is bad. So new one's installed. It should work. So we'll turn this on, and I'll let you see just how long it takes for us to see a picture and how bad this looks, and it's just not good. So here we go. 1, 2, 3. Okay. Come on. I don't hear any cracking. And, well, it came up a little bit faster than I expected, quite honestly. Let me go ahead and adjust our focus here. Actually, you know, let me get the camera set up. First here. Alright. And, okay. Let's adjust some focus. Ah, beautimous. Okay. Now let's get some... Oh, we gotta turn our yoke slightly. There we go. I'll say about there. Okay. Let's turn all of our color pots to center. Alright, so that is with all of our color pots in the middle. All 6 of our color adjustment pots are dead center, and that sucker is super green. Green, green, green. So we have a weak blue gun and a weak red gun. I had the green cutoff turned completely down. Drive down. Let's turn our brightness back up. And you can see here that our background is not black anymore. So we'll turn this back down until the background is just black right there. So yeah, this tube is super dim and tired. Look at this. We've got almost no red. I'll put all the color pots dead center. So here is green. So all of our color pots are dead center. I'll let you look here. You can see that all of our color pots are right smack dab in the middle of their adjustment, which is where they should be if you have a healthy tube. But as you can see, we have overly green and no red whatsoever, and it's just bad. If I turn the brightness down so the background is black, right there, right there. So with all of our color pots dead center in the middle, brightness adjusted to where it really should be, where the background is black, you can see we have no red and no blue. This tube, done. And I have already shot this thing twice, and there's no bringing it back. So let's turn up our blue drive. That's blue drive maxed out. We'll turn up our red drive. That's red drive maxed out. Turn up our red cutoff, and it bleeds. Blue cutoff. We do have some blue cutoff, a little bit more green, a little bit more, but our red, it bleeds. That's the maximum output of our red without it bleeding. And you can see it is weaker than the other two. And right now this screen is overly blue, way too blue. Let's turn our cutoff back down. Yeah. There's just no saving this tube. It's already, the red and the blue gun are just kaput. There's nothing to do, no way to save it. So what we're gonna have to do is I'll have to see if I can find the picture tube, and we'll have to swap this yoke over and try and work some magic, see what we can figure out. But the chassis has now been resurrected. That was somewhat quick and easy. It was a little flyback explosion right in front of your very eyes. So I'll find a tube and we'll see if we can work some magic. So here's an example of what I'm talking about. So this is my test tube that I use for testing all of my 19-inch standard res 7000s. I took the yoke off of it and I put this all-in-one yoke on here, and you can see that it doesn't go all the way forward. This is the maximum that it goes forward because the angle, the tube, the circumference of this tube around the neck is thicker. It's bigger than the other one. It's a different angle of deflection, so I can't slide this one forward enough for it to work properly. So if I turn this on and turn the monitor on, it looks like this. See this here? This curve and the purity problems. So you can see over here I don't have that curve, but I have the purity issue. And over here I have this curve because the deflection is different because I can't slide this far enough forward on the actual neck. If I take this and slide it backwards, if I slide this backwards, you can see how it kind of gets even worse here. And the farthest that I can slide it forward is right there, and there's a big gap. See, there's no way to make this work unless you have the proper degree of well, the glass there. This one here is thicker, so I can't slide this all the way forward. That's the problem with this yoke, is you have to have the correct corresponding type of tube, and I'm not sure I have one. So I'll keep looking here, see what I got, put this one back together, and keep it for my test set. But I'll have to see if I can search through the stash and find one that this will work with and see how that goes. Well, I do not have a compatible tube for swapping this, so we're just going to see if we can try and work some magic one last time and give it some life, a little bit more life, and then while it's running at the arcade I'll try and find another tube in the meantime. But for now we'll go ahead and let's see, everything's down. Okay, so let's turn this on. We got heater voltage at 6.3. It only goes to about here on the scale because there's something wrong with the B&K 480 I'm using. It doesn't quite get to 6.3, but when you measure on the actual tube, I have the tube hooked up and everything, it's about 6.4. So with the knob set to 7 to 9 volts, and I have the heater cranked all the way, it's 6.4 at the actual tube. So this is erroneously reading too low, so don't worry about that. Just forget about that. So we'll go to heater voltage, I'm sorry, heater leakage. No heater leakage, that's good. G1, no leakage, that's good. Set G1 voltage, we want G1 to be 50, so we move up to 50. And now we want G2 cutoff. For red, we want to turn it to the first hash mark, which is going to be, well, the red's totally dead. We'll put it roughly right there. Okay, stay there. Green, we'll put roughly the same place. Blue, we'll put roughly the same place. Okay, so we know green is the best, so we'll go to green, we'll go to read emission, and I mean, that's good, but it could be better. I'm not going to mess with the green. If we go to blue, blue is the, oh, I thought green was the best, but blue is the best. Blue is really good. 1.4 is about where the average good tube is set to. So blue is good. Green could be better, but at least it's in the good. Red, I'm expecting to go all the way down. Yeah, there you go. Red is no good. So I'm not going to bother with green or blue. I'm going to just try and zap the red. So set color tracking, we want, see, I can't even, you want the set tracking to be right there, and it won't even get close to it, and it's maxed out. So yeah, that's about the best I can do. So we'll go to rejuvenate for the red, and we're hoping to see it go up to about 1.6 and then slowly come back down. And I'm going to actually kind of tap on the neck while I do this. Just kind of gently tap on the neck. So I'm going to tap on the neck, hit the button. We're going to hope for it to get up to about 1.6 and then slowly drift back down. It may kind of go back and forth and zap up to the top and come back down a bit. That's normal if that happens. So that means it's zapped itself pretty good. So I'm going to tap on the neck and then hit the button. We'll see what happens. Oh, it's no good. Yeah. It just immediately goes back down. No, it's no good. See, it's red's done. Tapping on the neck does nothing. Red is done. This tube is toast. Let's see if we can try and shock it back into working. Just hit the button a bunch of times. No, it never gets past 1.1. Well, there's 1.3. Maybe we can shock it. Like I say, I've done this twice already, and it works for a little bit, and then slowly just goes back to bad. So until I can find the correct angle of tubes, I think this is a 100-degree one. I'm not 100% positive. I'm not really sure how to tell, quite honestly. But it's obviously, as you saw there in the video or the portion of the video just a moment ago, you have to have the correct size of angle of deflection on the back of the tube there for this particular all-in-one to work. Yeah, there's no bringing this red back. It's done. Sometimes you can just do a quick burst and kind of shock it back into working. 1.1, a little higher. Now, see, now it's back to below. Yeah, there's just no real way to resolve this. Holding it. So normally what would happen was it would come up to about 1.4 and slowly come down, and then sometimes it might zzz and then come back down. That's a good indication of it actually working in my experience. But this one is it's just too far gone. The red is just done. Yeah. So let's go to clean and balance. We'll go over to blue. So for clean and balance, you want it to come up to about 1.1 and just kind of stay there. And if it slowly start coming down, that's normal, but you want it to stay there for at least a little bit. So with the blue, it only gets to about 0.9. Yeah, see, this tube is it's just done. It's just done. See how fast that comes down? That should not do that. It should come up to about 1.0 and hang there for a little bit. And coming down is normal, but it should stay there for at least 2 or 3 seconds before it starts coming down. But that's just, yeah, there's nothing I can do about this. It's just done. Green. See, that's more normal. It's hanging out there about, up. Dancing around there, and that goes down. So that's more normal of what we expect to see with the blue. But blue just comes right down immediately. And, yeah. Red, I'm not expecting red to really do much here. Yeah, 0.6 is the highest it goes. The red's just done. Well, that's a bummer. I'll have to adjust this to the best that it could possibly be. And just live with it until I can find the correct angle tube for a donor, because right now I went through my whole stash and all the ones I have are like the 110 degree or 90 or whatever it is, with the yoke that looks like this, the ones that look like this with the rings and everything. I don't know if those are the 110 or the 90, but it's not right for this tube or this yoke on this tube. So the red is done. Yeah. Oh well, let's see what it's doing after this. No sense in even bothering to keep trying. Let's see what it's doing after this, and kind of hope and pray and cross our fingers. Alright, TPG is hooked back up. We're all set and ready for power, so let's see what it looks like. Oh, and all the color pots are still dead center, so what we'll see here is with all the color pots centered, and I don't know, let's find out. 1, 2, 3. It's relearning itself, and I don't have an image. No. I think I have now killed it. I think it's dead now. Let's go to the, oh, what in the world? What in the, oh, wait a minute. I think H position's way off. Oh, no. Hold or position? Let's hold. Explain to me what in the world's happening here. Oh, well, I was on the wrong screen. That's what I was doing there. Okay. Well, that was weird. So right there's where our black level needs to be, and the red is still done. Nope. Well, I don't know what the heck was going on there. I was just having a big brain fart, I guess. But okay, and something else to note is that the TPG actually puts out a higher video signal, so with an actual PCB it'll be even darker. So I mean, I don't know. Right now the red drive is completely turned off, or all the way down. If I turn it up at all, it just bleeds. If I turn up the cutoff, it just bleeds. So that's the limit of what I can do with red, and red is just super bad. There's green, wow. Blue, wow. And, I mean, what is this here now? What is going on here? I don't understand what's happening. Oh, bad connection on the TPG. Ah, this is just, man. Yeah, I got a bad connection on my TPG here. There we go. Man, I can't win for trying here. Turn our blue down. Turn our red back down. Yeah, that's what the red drive... Right now, red drive is completely off. If I turn it up even the slightest, it just bleeds red. Turn our green down a little bit. Yeah, I mean, it's just... Red is just done. There's nothing I can do. I mean... Alright, well, I'll spend a little time here trying to dial some stuff in, and I'll cut back and we'll see how well I can make... Whoa, whoa! Oh, whoa! Whoa! This tube is now dead. There's nothing I can do now. Okay, maybe not. What you saw there was a short on the G2 there, I think, inside the tube. The tube. You could hear it. You heard that also, but it's not uncommon for something like that to happen after you do a rejuvenation. It's very common for something like that to happen. But this is the third time I've tried to zap this, and there's just no bringing this back. So what I was saying, I'll cut away here, try and make some magic happen, do some adjustments, and fiddle with some stuff and see what I can do. But don't hold your hopes up, or don't get your hopes up. Don't cross your fingers. Don't expect much. But I'll see what I can do, and come back for a final end result, and have to live with it the way that it is until I can find a replacement tube. So hold on one moment. Okay, I've switched to the iPhone here because it kind of captures the refresh rate a little better than that other camera on the tripod. So again, this is about the best I can make it look. There's nothing I can do with it. So I went ahead and spent about 10 minutes adjusting colors and brightness and turning the brightness all the way down, contrast all the way down, screen voltage up until I get the retrace lines, screen voltage back down till the retrace lines just go away, adjusting brightness and contrast as needed along with the colors, and this is the best that I can make it look. It's not terrible. It's better than it was. There is still a little bit of some red. I mean, you can read the hot times there, and you got the midway, and I mean, as dead as that red gun is, it's still, this is the best result that I can get with this tube, and it's obviously very usable. You can see it and play it, and the red is more red in person. It looks bad through the camera here, but in person it's actually somewhat fairly red, along with the Golden Gate Bridge there. It doesn't look as good in the camera, but I guess the important thing here is after it's been running for about 15 minutes or so here, and it's warmed itself up, it stopped doing the zapping issue and all that stuff that comes with it after you do a rejuvenation. So this is about the best result that I can get with what I've got on hand here. And I don't have a tube that I can use to obviously swap this yoke onto something else, and it's nice and secure. I got it all tightened down and everything is working. So I mean, you can see it does have some red there. I was able to get fairly decent amount of red back into it, but when you have this screen, it looks not as red because of the other colors on the screen. When it's just only red, it's not too bad. So it's back to life somewhat. I do need to try and find a tube, but otherwise this is the best result I can get. So that being said, I appreciate it. Hopefully you learned something. Make sure you like, share, and subscribe. Comment down below, and I appreciate it. We'll see you on the next video. Oh, and stay tuned, because if I do come across a picture tube that I can use for swapping out, I will absolutely do that. And I'll probably have to fiddle with some adjustments again once I get this back in Paperboy. But for now, on the test setup here, it's doing much better than it was, and you know, as good as I can get it. So thanks again, and stay tuned, and we'll see you next time.